Hello students, in today's lecture we discuss about the radiopharmaceuticals. What is the definition of radiopharmaceuticals? What are the uses of radiopharmaceuticals? Areas where radiopharmaceuticals can play an important or vital role that we will discuss in today's lecture. So first we will find out the area which we are going to cover in the today's lecture. We are going to cover here what are radioisotopes, what is radioactive decay, what is the unit which is used for the measurement of radiation, what are radiopharmaceuticals, properties of an ideal diagnostic radioisotopes, then radiopharmaceutical categories and production, radiopharmaceuticals quality control, radiation measurement, application of radiopharmaceuticals in various fields, journey of radiopharmaceuticals that we are going to discuss in today's lecture. First we start from the definition of radioactivity. So actually radioactivity, it is a spontaneous and continuous emission of a radiation by a radioactive substance that is termed as a radioactive. So what is radioactive decay? An unstable atomic nucleus spontaneously loses energy by emitting ionizing particles and radiation. That is a radioactive decay. So radioactive isotopes forms parallel nuclide, forms a dot nuclide. When an unstable nucleus decays, it may give alpha particle, that is or helium radiation, beta particle or electron radiation, and it may give a gamma radiation. What are the various characteristics of alpha particles or alpha particle decay? Alpha particles are made up of 2 proton and 2 neutrons. These are same as a helium nucleus because helium also has 2 proton and 2 neutron. When a nucleus emits alpha particles, its atomic number decreases by 2 and its mass number decreases by 4 units. Alpha particles are relatively slow and heavy. Alpha particles have low penetration power as compared to the beta and gamma. As they have a large charges, alpha particles ionizes other atoms strongly. Alpha particle decay occurs in very heavy elements like uranium and radium. These were some special characteristic features or properties of alpha particle. Now we will discuss about the beta particle. So beta particles are same as electron as they have a charge of -1. As we know that electron is having a -1 charge. Similarly, beta particles do. When a nucleus emits beta particle, the atomic number increases by 1 and atomic mass remains unchanged. Beta particles are fast and light. Beta particles have a medium penetrating power as compared to the alpha and gamma. Examples of radioisotopes emitting beta particle is phosphorus 32. These particles ionizes atom. They passes, but they do, but not as strongly as alpha particles do. We discuss about here now the gamma rays. Gamma rays are waves and not particles because alpha particle, beta particle, but gamma is a rays. So gamma ray, it is a not particle, but it is a in the form of energy. Gamma rays have no mass and no charge. They do not have any mass and they do not carry any charge. Gamma particles atomic number and mass numbers remains unchanged. When any radioactive substance emits gamma radiation, its atomic mass and atomic number remains unchanged. Gamma particles have high penetration power. They do not directly ionize the other atoms. We don't find pure gamma source. They are emitted along alpha or beta particles. Useful gamma source include technetium-99. It is used as a tracer in medicine for the purpose of diagnosis. This is a diagrammatic presentation of depth or power of penetration of alpha, beta particles and gamma radiation. We can clearly understand from the diagrammatic presentation that alpha particles can be stopped by paper, beta particles stopped by the aluminium sheet, whereas gamma radiations only stopped by the lead block. These were the properties of radiation of alpha, beta and gamma. Alpha particle carries 2 unit positive charges. Beta carries 1 unit negative charge, whereas gamma has a no charge. Mass of alpha particle is 2. Beta particle do not carry any mass and gamma also doesn't carry any mass. Now we discuss about the ionizing power. Alpha has a very high ionizing power, beta particle has a moderate ionizing power, whereas gamma particles have a low ionizing power as compared to alpha and beta. Now, what is the depth of penetration? In air, alpha particles depth of penetration in air is less than 5 centimeter. Beta particle is less than 1 meter, whereas gamma radiation less than 1 kilometer. Means gamma radiations has highest penetration power as compared to alpha and beta. Alpha particles stopped by paper, beta particles stopped by aluminium, and gamma radiations can be stopped by the use of lead block or lead element. So these were certain characteristic features of alpha beta particles and gamma radiations. Now we discuss about the half-life. The half-life of radioactive is the time for radiation level to decrease to one half of the original value. It means that half-life is nothing but the time taken by the radioactive substance to decay to half of its initial amount. That is known as a half-life period, and it is denoted by capital T or small t and half. Naturally occurring half-life or radioactive substances naturally occurring tend to have a longer half-life, whereas radioactive substances used in nuclear medicine have a short half-life. In the below tabular format, some radioisotopes with their half-life period will be shown over here. Carbon-14 having a half-life 5730 years. Potassium-40 having a half-life 1.3 into 10 to the power 9 year. Radium-226 having a half-life 1600 year. Uranium-238 having a half-life 4.5 into 10 to the power 9 year. Iron-59 half-life is 46 days. Chromium-57 28 days half-life, and iodine-131 having a half-life 8 days. So these were the different radioisotopes with their different half-life. Now we see the radiation unit. These are the units. By using these units we can measure the extent of radiation, or we can measure the radioactivity of any radioactive substance. First unit is Curie, represented by capital C small I. It measures the activity as the number of atoms that decay in 1 second. Next unit is RAD, that is radiation absorbed dose. It measures the radiation absorbed by tissues of the body. Another unit of radiation is REM, that is REM, radiation equivalent mass. It measures the biological damage caused by the different types of radiation. Next is becquerel. It is represented by capital B and small q. That is BQ, 1 BQ, that is 1 becquerel is equal to 1 disintegration per second. DPS, disintegration per second. Next unit is sievert. It is represented by capital S and small v. 1 sievert is equal to 100 REM. Next is Gray, represented by capital G and small y. 1 Gray is equal to 1 joule per kg. These are the radiation units. Now next is radio-pharmaceuticals. Actually, radio-pharmaceuticals are the radioactive substances which are used in the field of pharmacy. That's why they are called as a radio-pharmaceutical. Otherwise, there is not any kind of difference between the radio-pharmaceuticals and the radioactive substances, because these are the same radioactive substances, but they are used in the field of pharmacy. That's why they are known as a radio-pharmaceuticals. These are medical formulations containing radioisotopes composed of two parts, radionuclides and pharmaceuticals. What are nuclides? Any species of atom characterized by a specific number of neutrons and protons within the atom are said to be a nuclide. Radiation measurement. There are different devices which are used for the measurement of radiation. Any radioactive substance, what type of radiation and up to what extent that radiation is emitted by that radioactive substance, various tools or equipments used for the measurement. So first equipment used for the measurement of radiation is GM counter, that is Giger-Muller counter. It detects the beta and gamma radiation. What is the extent of beta radiation and beta particle and gamma radiation emitted by the radioactive substance? It is also used It also uses ions produced by radiation to create an electrical current. So it is a gaseous ionization detector. What is GM counter? It is a gaseous ionization detector and uses the Townsend avalanche phenomenon to produce an easily detectable electronic pulse from a little as a single ionizing event due to a radiation particle. A gas ionization process whereas free electrons are accelerated by an electric field colloid with gas molecules and consequently free additional electrons. This is a diagrammatic presentation of GM counter or Giger-Muller counter. It comprises of a window and a metal tube which itself acts as a negatively charged body or negatively charged electron. An inert gas is filled within the chamber. Then at the center of this cylinder coaxially an electrode is mounted which itself acts as a positively charged electrode. Both these electrodes were connected to each other by the application of high electric voltage, and the pulse or impulse which is generated after the elimination of alpha beta particle and gamma radiation from radioactive substance, it will be measured with the help of galvanometer which is connected to the two electrodes. Application of radiopharmaceuticals. What are the various uses or application of radiopharmaceuticals? So first, it is used in the treatment of disease. So radiopharmaceuticals are used in the treatment of diseases, that is known as a therapeutic radiopharmaceuticals. They are radio-labeled molecules designed to therapeutic dose of ionizing radiation to specific diseased sites. Some examples were quoted over here. First example is chromic phosphate, that is P32. It is used for lungs, ovarian, uterine and prostate cancers in the treatment of cancer. Next is a sodium iodide, that is iodine, that is I-131. It is used for the treatment of thyroid cancer. Samarium, that is SM-153. It is used for cancerous bone tissues. It is used in the treatment of cancer of bone tissue. Sodium phosphate P32. It is used for cancerous bone tissue and other type of cancers also. Strontium chloride SR89. It is used for cancerous bone tissues. Erbium 169 for relieving arthritis pain in synovial joints. These were the radiopharmaceuticals. There are different applications. Second application of radiopharmaceutical is it is used as aid in the diagnosis of diseases. These were used in the diagnosis purpose. Diagnosis purpose also plays an important role in the diagnostic case. The radiopharmaceutical accumulated in an organ of interest emits gamma radiation, which are used for imaging of the organ with the help of an external imaging device called gamma camera. It is a camera which emits gamma radiation, on the basis of which any organ can be examined or the functioning of an organ can be examined, or if there is any presence of any kind of tumor or infectious tissue, cancerous tissue, that can also be detected with the help of these radiopharmaceuticals. Radiopharmaceuticals used in cancer technique for measuring physiological parameters. Use the example of chromium 51 EDTA for measuring the glomerular filtration rate. Radiopharmaceuticals for diagnostic imaging. Example, it includes the TC99 methylene diphosphate MDP used in the bone scanning. That is used in the bone scanning. This is a journey of radiopharmaceuticals, which is represented with the help of flowchart. Radionuclide generation, forwardation to give a radio tracer production, then patient's exposure, radioactive decay, gamma ray detection, and then image reconstruction, which helps in the field of medicine also to identify for the diagnosis and in the treatment of various kinds of disease and disorders. That's all for the radiopharmaceutical and pharmaceuticals and contrast media. Thanks for watching. Thank you.